Hey everyone, we are Acrobat Adventures, and in today's video we are going to walk you through the basics of electrical systems. Before we start this video, it's really important that we mention we are not professionals, we are not electricians. We are just showing you what we've learned through research and by completing 2 builds of our own. If you have any questions along the way for yourself, we highly recommend that you talk to a licensed electrician for your specific build. We know that as you start learning about electrical systems, it can be very intimidating. There's all these wires, fuses, things that you have to worry about. All that can be overwhelming, but we're going to walk you through it in a really simple way today so you feel comfortable with the whole thing. At the very highest level, you might be thinking, what do I need for my electrical system? What you need is 1, a power source, which is likely a battery. 2, a way to charge that power source, and we'll talk about that in a minute. And 3, your actual electrical components that you're planning to use with your electrical system. So a battery or multiple batteries are your main power source, which actually provide electricity to all the components throughout your van. So whether you're running a blender or charging your phone, the battery is really where that electricity is coming from. There are a couple different types of batteries. The 2 most common in builds are AGM batteries or lithium batteries. Lithium batteries tend to be more expensive, but they're much lighter. You can use the full amount of battery power and drain it all the way to 0 with no negative consequences. And they tend to have a longer life expectancy in the long run. AGM batteries, on the other hand, tend to be much cheaper, but they're a lot heavier, they take up more space, and you can only discharge them to 50% or it's going to negatively affect the life of your battery. So if you're looking for the best of the best, lithium is probably the way to go. But if you're trying to save some money in your build and you can spare the weight and space, then maybe AGM batteries are for you. When deciding how big your battery bank needs to be, you really just need to think about what kind of electrical components you plan to use. Are you planning on having a gigantic refrigerator? Do you think you're going to use a blender every day? Are you going to be powering a table saw from your build? Really, the size of your battery bank is just dependent on how long you want that electricity to last, which is mostly determined by the types of components you're using and how frequently you're using them. If you're just running little light bulbs and charging your phone, you probably don't need that much electrical power, but if you're using bigger components like refrigerators, you might need a little bit more battery power to last you a long time. In our build, we have 250 amp hours of lithium battery power. We're running many electrical components, but a lot of them are DC power and very energy efficient. And that can last us probably a week, if not 2, completely off-grid without having to recharge our batteries. We haven't fully tested it, but honestly, it might be more. Like, it might be 3 weeks, a month, even longer. Just depends on how much we're using. If we were to use our blender every day for 3 meals a day, that might go away a little bit quicker. If you have more questions about batteries themselves, feel free to comment below or send us a message on Instagram. The next most important thing is a way to charge and recharge your battery. There are 3 main ways that we've seen this done. You can do solar power, which charges your battery from the power of the sun. You can do an alternator charger, also called a DC to DC charger, which will actually charge your battery while your car is running. So anytime the engine is running, it's charging your battery. And the third method is called shore power, which means you're actually plugging in your electrical system to a house electrical outlet or a campground outlet, and you're taking power from a normal house or something and putting it into your battery. We actually chose to install all 3 of those charging methods in our build, and you can watch how we installed them in our other build video here. So we went with all 3 methods because we're not usually parked somewhere where we can plug in shore power, but it's nice to have when we are parked near a house or a campground. We do drive a lot, which means the alternator charger is a great option, but if we're parked somewhere for a long time, it's not going to be able to charge our batteries. And solar tends to be our main charging source, but if it's cloudy for a long time or you're parked under some shade, that's not going to work, so you need some other way to make sure your batteries can stay charged. So solar panels are mounted on top of your vehicle so they can be exposed directly to sunlight. You can either wire them in series or parallel if you have multiple panels, and we'll talk about that a little bit more in our actual installation video. But for this video, all you need to know is that your solar panels will actually take the electricity from the sun and then put that into your battery. The way it does that is with another necessary component called a charge controller. And what that does is it regulates your solar energy and converts it into a form that is okay to charge your battery. So it makes sure the voltages are aligned and the current is appropriate to actually go into your battery. One common question is, how much solar power do I actually need to charge my battery? A rough rule of thumb is that for every amp hour of AGM battery, you need 1 watt of solar on your roof. So if you have AGM batteries and you have 200 amp hours total, you probably need about 200 watts of solar on your roof. For lithium batteries, you need about 2 watts of solar for every 1 amp hour of battery power. So if you have a 200 amp hour lithium battery, you need 400 watts of solar. I'm not going to go into a super detailed explanation of why that's necessary, but the basic gist is that 100 amp hours of lithium is worth about the same as 200 amp hours of AGM. And that's because with AGM, you can only discharge the batteries to 50%, whereas lithium, you can discharge it all the way to 0 with no negative consequences. So you have to think, 100 amp hours of lithium battery is worth twice as much as 100 amp hours of AGM batteries. So if you do decide to go with solar, you can get solid solar panels, which tend to last a bit longer, or you can get flexible solar panels that kind of stick to your roof. In either situation, you want to make sure they are securely fastened to your roof so that when you drive at highway speeds, they do not come flying off. If you decide to install solar panels as one of your charging methods, you're going to need the actual solar panel itself and a charge controller, which monitors that voltage going into your batteries, along with some wires and fuses, which we'll talk about in a little bit. If you want to charge your batteries with the alternator of your vehicle, so while the vehicle's engine is running, you're actually charging your house battery, you need what's called a DC to DC charger, also called an ACR sometimes, or an automatic charge relay, or some components are called an isolator, which basically isolates the 2 batteries. A DC to DC charger basically connects your vehicle's battery, which gets charged while the engine is running, to your house battery, but only during appropriate times. So it will only allow one to charge the other when the vehicle is actually running, and it only allows the appropriate current and voltage to go into that battery based on some settings that you configure while you install it. It's really important that these 2 batteries are only connected while they're running or when you want them to be, because if they're connected all the time, if one battery gets depleted, it's also going to start depleting the other battery. For this reason, we recommend a DC to DC charger or an automatic charge relay that has some kind of sensor that knows when the vehicle is running over an isolator, because sometimes the isolator doesn't know when to disconnect the 2. So in order to charge your house battery with the vehicle's engine, you need a DC to DC charger, appropriate wires and fuses, which we'll talk about in a minute, and you need to make sure that your DC to DC charger is appropriate for the types of batteries in both your engine and your house battery. So because we were running lithium batteries, we needed to make sure that our DC to DC charger was appropriate for lithium batteries. Sometimes that is not the case, so make sure you read up on the type of DC to DC charger you buy to make sure it's compatible with your battery type. The third method of charging your battery is by shore power, which means you just take an extension cord, you plug it into a house, and then you plug it into your vehicle somehow. In order to do that, you need a component called a charger, which is often combined with an inverter, so you can get a component called an inverter charger. We find that this is our least frequently used method of charging our batteries because the solar tends to be enough. We drive quite a bit, so that will be our second method, and we're not usually parked somewhere that we can actually plug into shore power. But if you think that you're going to be parking at campgrounds with electricity or outside of a friend's house where you can plug into their outlet, this might be a good method for you. In our build, we're using an inverter/charger, which means it can either invert or charge. We'll talk about that in a minute. But that basically saves us another component. It allows the whole thing to be done in one unit. They are a little bit more expensive than standalone chargers, but you probably are going to want an inverter anyways. So what is an inverter? If you want to run normal 3-prong outlets like you might see in a house for a blender or a normal electrical component, you need to have something called an inverter, which converts a 12-volt battery into alternating current like a house uses. So anytime you see high tension wires or an outlet in a house, it's using AC or alternating current. It runs at a different voltage and it is basically a different source of power. A battery is 12-volt DC direct current, which operates just in a different way than AC current. If you think about a car outlet, often called like a cigarette lighter outlet or something like that, It's a circle, and you just stick like kind of a weird thing into it. That's a DC outlet, which means it's direct current. It's basically coming directly from the battery into there. If you think of, in the US, the 3-prong wall outlet, that is alternating current, and they are basically two completely different plugins. You're not able to plug in your laptop charger or a blender into that carport. It's kind of a similar thing. You need to convert the electricity to run in the correct way. So if in your build you think you want to be running anything with electricity with a normal outlet plug, 3-prong in the US or maybe 2-prong in Europe, you need what's called an inverter to change that battery's direct current into the house alternating current that you're used to seeing. We do use an inverter and run alternating current to run things like our electric water heater, a blender, to charge our laptops, a lot of other things like that. But the one thing to be aware of is that converting your DC battery into alternating current is not very efficient from an electricity standpoint, and will deplete your battery power pretty quickly. In our last build, we actually had a normal alternating current refrigerator that we bought from Walmart. The refrigerator was very, very cheap, but it did drain our electricity quite quickly, so we had to keep our inverter running all the time. We always had to be monitoring our battery bank to make sure that we weren't dropping below that 50% mark. In this build, we've switched to almost all 12-volt components, so even our refrigerator is running on 12-volt power, which saves a lot more electricity than running an alternating current inverter all the time. So to wrap it up, if you do want to use alternating current like a normal house outlet, you will need what's called an inverter, and you will need to work that into your electricity system. So up until this point, we have a couple of main components. We have the battery, either AGM or lithium. We have a solar panel and a solar charge controller, which allows you to charge the battery from the sun. You might want a DC to DC charger to allow you to charge the battery from the engine. You might need a charger, which is the actual component that allows you to charge from shore power to your 12-volt battery. And if you want to use AC outlets, you need an inverter. So those are kind of like the main big components that you might want to incorporate into your electrical system, but all of them definitely need a fuse block or a breaker block so that you can appropriately fuse and monitor electrical currents for safety. In any electrical system, you absolutely need fuses or breakers, depending on the type of electricity, because they limit the amount of flow that can go through a wire, and they are your safety point if something were to go wrong. So the goal is that your fuse would break first to protect you from any kind of electrical fire or electrical failure in your system. Fuses are an extremely important part, and you might be thinking, how do I know what fuses to use and how big of a fuse do I actually need? So fuses are what are used for DC electrical currents, while breakers are what are used normally for AC electrical currents. Breakers are resettable, so if it goes over the limit, it will trip the system, but then you can basically flip it back and it will work again. Fuses are one and done, so if you go over that electrical limit, the fuse will break and you actually have to replace the fuse itself. Any of your electrical components will actually recommend a fuse and wire size for that component. So when you buy an inverter or a DC to DC charger, it will basically say in the owner's manual, you need to use this size fuse and this size wire so that you can be safe in your system. So whether you like it or not, you probably have to read the owner's manual, and it's very important that you do so and incorporate those fuses so that you keep yourself and others safe. Again, this is really high level, so if you have any additional questions, feel free to drop them below or write a message to us. Next, we need to talk about wire size. Wire size also corresponds to safety and is dependent on, one, how long the wire is, so how far from point A to point B, and two, how many amps we think are going to be going through that wire. So you'll notice on most electrical systems, the wires that directly connect to the battery or to the inverter, components that can have a lot of amperage going through them, you'll see these gigantic wires. They're much bigger, but on your actual wiring to an outlet or to your light bulbs, you can use a lot smaller wires. The goal is to make sure that your amperage never exceeds the wire limit for a specific length of wire. You can actually Google on different websites what size wire you need depending on the current flowing through it. We'll link a couple of those resources below in our description. But again, you have to think about what component you're going to be using and then read that owner's manual to see what the maximum current allowed to it is. The way I like to think about these electrical systems is that you have this big battery bank, but each individual component has to actually ask for an amount of electricity. So let's say you have a light bulb. When you turn it on, it's basically asking for a specific amount of current. In a light, it's usually a very small amount, so maybe it's 1 amp, 2 amps, but that light could never exceed some kind of value defined in the owner's manual, and let's say that's 5 amps. If the owner's manual says it's 5 amps, you have to get a 5 amp fuse and put that as close to your battery as you can, because you don't ever want that light to receive more than 5 amps. If it does, that might cause some kind of safety issue, could create a fire. We don't want any of that. Second, you have to figure out what kind of wire can handle 5 amps for that distance. So you would go to some kind of resource like the chart linked in the description below. You would say, I need to have 5 amps for 10 feet to get from my battery bank to this light bulb. And it'll actually say in the chart, you need wire size X. Wire sizes are defined by gauges, and the smaller number of your gauge is actually a bigger wire that can be handled for more amperage. So in that example, 12 gauge wire would actually be able to handle more amps than a 16 gauge wire. So again, the smaller number means more amps can flow through it. In general, it's safer to use a bigger wire than you think you might need because you're really trying to prevent an electrical fire. You don't want to go too big because the bigger wires tend to be more expensive, and there's something called voltage drop. I'm not going to get into it, but basically it can become less efficient if you use too big of a wire. You don't really want to use a gigantic wire going to your tiny little light bulb. It doesn't really make any sense. It would cost you a lot of money, and that's really the main point of it. But when in doubt, I would use a little bit bigger size wire than you think you may need. So similar to your light bulb, every single component in your electrical system could ask for an amount of electricity. Your inverter could, your DC to DC charger can, anything like that might ask. I'm saying ask, it doesn't literally ask. Any component could basically try and get a certain amount of electricity from your battery. The fuses or breakers are there to protect you if that component accidentally asks for more electricity than it should have. For example, if you have an outlet and it's rated for 10 amps, you have a 10 amp fuse and your wires are appropriately sized to handle those 10 amps. If you were to plug in something that uses a lot of electricity, like a toaster or a table saw, something like that, and you try to run it, that piece of equipment is going to be asking for potentially more amperage. A table saw tends to run at 15 amps, so it might say, I would like to use 15 amps. When that happens, the fuse will not allow it. The 15 amps will try to come in, the fuse will break, and that will keep you safe because the wire will not have more amperage than it's rated for. If you were to skip the fuse and you put that table saw on, you flipped it on, the wire rated for 10 amps would request 15, and when too much electricity is flowing through that wire, it actually could cause a fire, putting yourself and a lot of others at risk. So fuses and wire size are the most important part of your entire electrical system. The last important safety feature that I do want to talk about is a master kill switch. Basically a way to completely disconnect your battery from the other components that are in your electrical system. It's really important to include something like this so that in an instant you could flip that switch off and disconnect any electricity flowing to your other components. This is extremely important if you're deciding to work on your system in the future. If you have to add an additional component, anything like that, you need to make sure there is absolutely no electricity flowing to what you're working on, so that you can keep yourself safe. What that means is you need to have a kill switch between anything that can provide electricity to where you're going to be working. So the battery itself can provide electricity, but also your solar panels can provide electricity. A lot of times we see solar diagrams where the solar panel is wired directly into your bus bar, which means it's actually connected to your components itself. When you wire it this way, if you disconnect your battery, but it's sunny out, you actually still might be providing power to your light bulbs, which is unsafe. Because if you need to rewire that light bulb or disconnect it, you're actually still going to have electricity flowing to it, which could put you in a dangerous situation. The way that you can handle that is by either adding another on-off disconnect switch to your solar wiring, which means you can completely disconnect your solar panel from the rest of your system, or by connecting your solar panel to the battery, where it won't have the ability to provide electricity directly to your other components. Once you have all of your electrical components, the next thing to think about is how are you actually going to connect those pieces together. There's a lot of different types of connectors out there, and it's important that you actually connect things in the right way. With big wires, there's something called wire lug terminals. They tend to be a solid piece of metal, like copper, with a hole in the middle. That allows you to actually put that end through some kind of bolt, screw a nut on, and you know that it's always going to be locked in there. When you have big wire sizes, it can be really hard to actually crimp those metal connectors on. So we strongly recommend that you get a hydraulic wire crimper so that you can apply the appropriate force to them. When you connect your wire to your lug terminal, it should be able to hold quite a bit of weight. You should not be able to easily just jiggle it off. Any loose connection can be a safety issue in your electrical system. For smaller wires, they have a very similar thing called a ring terminal. The only difference is that you usually don't need a hydraulic wire crimper to put them on. So these look like a little ring. You slide the wire on, and then you can use a hand crimper. You basically squeeze the metal onto the wire. Then it becomes a very secure connection. You can't pull it off easily. And now your wire is able to slide onto something like a screw or a bolt where you can lock it in place. For any of these connections, we recommend that you use waterproof heat shrink tubing. That basically provides an extra layer of security between your ring terminal and the wire itself. When you use this heat shrink, it creates a watertight seal between the ring terminal and the wire coating itself. This also can be helpful in any type of electrical system that is humid, like a van, or exposed to water ever. There are also some other connections that you might see that we've used throughout our build. One is a Spade terminal. These are the kind that you basically slide one into the other. They work similar to ring terminals where you take the Spade female or male end, you crimp them onto the wires, and then you can connect them quickly. These are great when you're installing because they're very easy to put together. The only issue is in a moving van, they could jiggle apart over time, creating a loose connection and making some of your components not work properly. So we generally recommend that you use a solid connection anytime you're doing wiring in a vehicle. Sometimes you'll actually have to join two wires to each other. In this case, you can use what's called a butt splice terminal. It's actually called that. Jesse's laughing. Basically, it's a little union where you can put one wire in, crimp that side, put the other wire in, crimp it, and now the two wires are connected as one. The last scenario that's pretty common is to need to connect more than two wires together. What we found is the easiest is what's called a lever connector. These are extremely easy. You basically take the wire, you stick it in this hole, and then you flip a lever down and it locks in place. Again, these might not be the most secure connections in a moving vehicle that jiggles, but to combat that, we tend to wrap some electrical tape around it, make sure all the wires are really secured together, and then wrap that tape around the lever connector itself. Really, you just want to make sure that the connections stay in place over time as you're driving and the whole vehicle is moving. That's the overview of different electrical connections, but for more detail or to see how we actually do that, you can watch our other videos where we walk through our various electrical installations. A few other safety considerations. In a moving vehicle, it's strongly encouraged that you use stranded wires instead of solid copper. The reason is that solid copper becomes brittle as it vibrates, which means the wire could just break, becoming unsafe and potentially creating an electrical hazard. Stranded wire is actually required by law for most RVs and definitely for any marine applications. So for that reason, we choose to use marine grade stranded wire, knowing that that is the most safe option for our vehicle. If you do install electrical outlets like your house, it's very important to use what's called a GFCI outlet. This means ground fault current interruption. These are the kind of outlets that you might see in a kitchen or bathroom with the little reset button on them. These outlets actually have an internal breaker in them, so if you were to get them wet or create some kind of electrical hazard, the outlet itself would be protected and protect the users of those outlets. Because you're going to be in a human vehicle, it could be exposed to rain or moisture. We strongly recommend that you do use GFCI outlets throughout your build. One important thing to note is that we will get into some extra details in our installation video, but you actually only need the first outlet to be a GFCI outlet in order to protect the entire current from any type of hazard like that. So watch our other video for more details, but know that you need at least one GFCI outlet per AC circuit. Again, we are just going to reiterate that it is extremely important to have the proper fuses and wire sizes, as well as appropriate shutoff switches so that you can limit electricity to various components of your electrical system. A couple of last important considerations are how you should lay out your electrical system. In general, it's best practice to keep your wires as short as possible, especially between large electrical components like your battery to your inverter. Most electrical systems also recommend that you don't run DC wiring and AC wiring right next to each other. They try to avoid that by spacing them out, or when they do need to crossing them perpendicular to each other so that you minimize the amount of time the DC current is overlapping with the AC current. When you're designing your system, I strongly recommend that you make it easy to get to your master kill switch. This is something that you should be able to get to and turn off in an emergency very quickly. Similarly, we recommend that your DC fuse block or your AC breaker box is also accessible. You don't want to really hide it in the back of your electrical system and make it impossible to get to. These don't have to be accessible in an emergency situation, but it's pretty common that a fuse might blow or a breaker might flip, and if you have to crawl through the back of your build and undo a bunch of crap, it's going to be really annoying when that happens. So in general, I recommend that you put your fuse block towards the front or somewhere generally accessible while you're installing your electrical system. The last thing to consider is how you're going to monitor your battery's level. We really encourage you to have some type of battery monitor. We've used the Victron one in our Go Power system. There's actually a battery monitor built in. But either way, you want to be able to see how much battery power you have so that you don't hit zero, you don't run out in an emergency, and you don't ruin your batteries by going below any kind of limit. If you want to see how we set up our electrical system, be sure to check out our other video up here. As far as tools go, what you're going to need are some big wire cutters. Most of these van or bus electrical systems have some pretty large cables, and typical wire cutters are not going to work. So this is probably about the minimum that you need, but got these on Amazon, they're fairly cheap. The second thing I super recommend is to get a hydraulic wire crimper. There are some cheaper versions available on Amazon, but I do not trust them. You have tons and tons of electrical current going through these wires. The last thing you want is for that to become loose and to fall off. This is like 50 bucks and will give you an extremely secure connection to all of your wires. So I very much recommend this. Anytime you're cutting your big wires, you need a new terminal for them to attach to your fuses or to your blocks, and what you buy are called lug terminals. So after you cut the wire, this is what you're going to put on there, and then you're going to use your crimper to lock it on there forever. Anytime you have these joints, it's important to make them as secure and waterproof as you can, so you can get this stuff called heat shrink. It starts out big, you put it over the wire, and then you heat it up with a torch or just a heat gun, and then it will shrink up super nice to make a watertight seal. It's very important for secure wires. And the most important part of your whole electrical system is making sure that your wires and your fuses are set properly. So there's a couple of different types of fuses we're going to be using. The most common is this A&L fuse. These have actual bolts that you go on there, so this wire, it will be a wire, would actually go through this, and then you can tighten a nut down on it and it will lock on. There are quite a bit of different guides and tutorials you can look up online, but it's important to just check what is the maximum amperage that can go through each of your wires. You need to make sure that your fuses are smaller than that number and that you're reading all the instruction manuals for all your parts appropriately so that you're not using any fuses that are bigger than you're supposed to for your system. So with the Go Power system, it recommends all the same fuses that you're going to need. It actually provides a lot of them for you. So that's really a relief. This is quite an easy package. It came with all the wiring diagrams, but we're going to show you what we do here and show you that you can do it yourself. So I just want to quickly show you how we can cut the wire and then connect to the wire lug terminals to it. It's really straightforward, but we'll walk you through it. You're going to take your wire cutters. This is 4-gauge wire. We're going to be using it for some of our electrical components. I like to just start with a nice clean cut at the end. So all you do is grab this and then squeeze. Now we have a nice clean cut. Then we have to strip the wire back a little bit. For these big ones, I just use a knife and really carefully do it. You take about, this is your wire lug, I take about 1/2 inch off the end. So just enough so that this will go into the lug. Just go around here. And we're just cutting through the plastic outside, the rubber. So now you can see there's a little portion where we have the actual copper stranded wire sticking out and then our rubber down here. Once you do that, you're going to take your heat shrink, put it over the wire, so it's just loose like that, you can see. And then we are going to take the lug and put it on top. And if it gets a little frayed, you can just kind of twist it yourself like that. We take the lug, same size for the wire, and you should put it on there like that. Now you need to get your hydraulic wire crimper for any of these big gauge wires. They come usually with multiple different sets of dies like this. So look at the manual, find your wire size, find the right die. We're using 4 gauge wire. The manual says we should be using this die with the number 25 on it. So really easy to do. All you have to do is take these and then slide them into the hole. So we have it now a top and a bottom. There's a little knob on the outside. We just spin it to the shut position. And then now when we move this handle, it'll start to crimp. So we're just going to do that to our lug we just put on. So with the lug on, I'm just going to put this in here. I kind of use one finger to make sure it stays in place. You can see that these dies are touching each other. So now I know it's crimped. And then to just check, this should be pretty tight. So if I give it a tug, I should not really be able to pull this off easily. So that's pretty good. I'm pulling pretty hard. It's not going anywhere. So this is good. And then the last step would just be to take your heat shrink, take your heat gun, and then start heat shrinking so that it seals the connection. This heat shrink is for a much bigger wire. It'll shrink quite a bit, but I don't think it's going to shrink this much. So we actually have to go to the store and get the proper size heat shrink. Okay, we're back with the right size heat shrink. All we're gonna do is cut a little piece of it. Get a small piece. We're just gonna slide the heat shrink over the metal and the wire. This is like a much better size. And then take your little torch and just heat it up. Start to shrink down. Awesome. And then we end up with this nice tight connection, and then that's it. We'll provide links to all the electrical components that we used in our build and some of the tools that we talked about in the description below. Please let us know if you thought this video was helpful. Thank you for watching. We are Acrovan Adventures, and we'll see you next time.